All right, welcome to Computer Science 305. This is our third look at Java, and today we're going to be talking about exception handling and error handling in the Java language system. So let's start out with a quick little demo, right? So we have create this little test class, right? Basically, it's just going to attempt to parse integers that are taken in from the arguments in the from the command line. So pretty simple, right? Okay, so the class is built. Now I just need to go and actually compile it. So do that by moving to the actual directory. Alright, so we run Java C on test. And as we can see, we have the class file. We'll go ahead and run it with Java. And it gives us one exception, which is array index out of bounds. But if we actually run it with the values that we need, it comes out with 2, as we expected. So we also saw if we just ran it with nothing, right, it gave us the array index out of bounds exception, as we expected to see. And then if we run it with 0, it should give us a divide by 0, right? As expected. So the interesting thing is exception handling is it's not new, but in the old languages, and this includes C and Fortran, COBOL, all these other languages that existed back in the day, they didn't really have a way to handle this. They would just fail and wouldn't really give you a lot of information on what was happening. And one of the things that we realized as engineers and language designers is that we need some other way, to give the programmer the capability to detect when this is going to happen and gracefully handle it. And so so this led to languages like Java, Ruby, Python, etc., being able to support what they call exception handling, right? Literally handling an exception. And so that's what like I said, that's what we're going to be talking about today. We're going to be talking about specifically in the context of the Java language system. So this is broken down to like 8 sections. It's going to be long, I'm sure, because I drone on. But anyway, I'll try to break it down, and we'll continue this part all the way up through 17.3, catching exceptions, and then we'll continue on from there. So it'll be multiple parts to this. So in Java, there are lots of different predefined exceptions, right? There's just like everything is an object, right? There's a base level exception. So, but there's some really common ones that I'm sure we've all seen. The first is the null pointer exception, right? This happens whenever we try to call a method on an object reference that is referring to the null. And then we have arithmetic exception we just saw is anytime we have a divide by 0 or any type of arithmetic operation that's not allowed. Obviously, array index out of bounds exception is when we try to access an index of an array that's greater than or equal to the size of the array or less than 0. And then finally, we have the class cast exception and string index out of bounds exception, right? The class cast exception occurs whenever we try to cast a object reference to a type not within the hierarchy of the type that it actually is. Right. Finally, we have the string index out of bounds exception. That one is essentially just like an array index out of bounds, except for here we're trying to access the character at an index that is -1, less than 0, or greater than or equal to the length of the actual string. All right. So we've seen all these, right? But we also need to know that exceptions are essentially just another type of object, right? So they have methods, they have fields, they have all the different things, right? but their names, like null pointer exception, is the name of their type. So and any exception that's actually thrown is just an object of those classes. And so what happens is when you go to for all the stuff that we've seen, whenever we're executing using the base Java library, it'll throw one of the common exceptions that we've seen. And when it does that, it automatically creates an object of the exception class and then throws it, which is just where it's producing it and causing a halt to the operation of the program. And if you don't handle this, you don't catch the exception, right, then it will terminate the program and throw with the error message attached to the actual exception. So essentially what these are is the base class for all this is the class throwable. And so there we have to understand what this is really talking about, right? So to be able to throw an exception of any kind, it has to be the object that you're referring to that you're going to throw must be derived from the throwable class, right? It's built into Java. It's a base class, and it really has. There's a throwable defines a hierarchy that are the basic foundations for all of exception handling in Java. So you have to realize there are these four predefined concepts, right? So we have throwable, which is actually an interface that is implemented by error and exception, and then a subtype of exception is runtime exception. So in Java, we can't handle errors. So errors happen, and they are not. Well, actually, we'll move forward to see what we see here. So you have object. Object then goes to throwable, and then you have error, exception, and runtime exception. And so classes derived from error are used for really extreme problems, things that cannot be recovered from. And so, for example, one would be the out-of-memory error that is spoken about there. Exceptions, on the other hand, are things that we can possibly recover from, right? And so there's two different kinds of these. There's the standard exception, or there's a runtime exception. Now, what matters here is when these must be handled. So if it's a runtime exception, this is something that only will occur during runtime, and it's not guaranteed to be thrown, and is not being. We're not forced to try to handle it, right? Because it occurs for typical issues like arithmetic problems, out of bounds errors on strings and arrays, things like that. These are only runtime issues, and we are expecting that as we program that we're not going to make these mistakes, so we're not going to try to catch these any possible time that they could actually occur. On the other hand, there are other types of exceptions, right? Any other type of exception that doesn't derive from runtime exception are going to be ordinary errors that we might want to catch and recover from. And so, but there are ones that we must actively attempt to try to catch. These would be like input-output type exceptions. So anyway, we'll kind of get a little bit into that. Moving into the next section, which is, how do we catch these exceptions? And so the basic construct for allowing us to do this is what we call the try statement. So there's actually two different versions of this. I think we're only going to cover one of them. So the try statement is really pretty. Is a pretty simple concept. It's a block compound statement, right? So a set of statements surrounded by curly braces, preceded by the try keyword, and then after that there's a catch, and in parentheses is an exception variable, right? And then another compound statement. So this is a pretty simplified version of what we can do with this. But basically, anywhere we put the code that is going to generate the exception inside the try block, and then if the actual exception occurs, it's going to trigger one of the catch blocks, because you can have more than one, and then we handle that. We deal with it, how the program moves on from there inside that. So the example will be here, right? We have our original code where we had this test. Now we know that it can throw an arithmetic exception, and it can also throw an array out of bounds exception, but we can deal with that one later. So the first thing we want to do is we're going to surround this whole thing with the try block, right? I think I can do this. Oh, this is not my IDE. So, okay. So we surround this whole thing with the try block, and then we need to catch the actual exception, right? So the arithmetic. Right, and then in the catch block is where we're actually do something, and here we're just simply stating that we're dividing by 0, right? So with this now, even if we try to divide by 0, we still won't get the exception to kill the program. So if we go ahead and run it, we'll recompile, and then say Java test and then 6.0. As before, it gives me my poorly written version. So it says you're attempting to divide by 0, as expected, right? But on the other hand, if we go ahead and run it with the 6.2, it gives us 3, right? So nothing really changes except for when the error occurs, it will handle and provide, it goes into the block that handles the code that actually matters here. And so, but yet again, if we were to run it as we did before, with no arguments, it still gives us the array index out of bounds exception, right? So we need to, if we were to write this in a fully developed way, we'd have to try to capture that exception, either by catching the arithmetic exception or by, catching the array index out of bounds exception as well as the arithmetic exception, or by adding a simple check to validate that we have the right number of arguments to be able to perform this program. So what we do need to know is that these types of exceptions that we are catching, arithmetic and array index out of bounds, yet again, are runtime exceptions. They derive from a runtime exception, and they do not require us to normally have to do a try-catch block for them. But when they do occur, it would be nice to be able to have a way to, move the program in the forward direction without having it just fail. So there's an interesting thing, right, is oftentimes, when we run the try, we have to understand how this thing works, right? So it's going to try to, in the try block, it will attempt to execute all of the statements. If everything executes correctly and you hit the end of the try block, it will bypass the catch. On the other hand, if an exception occurs somewhere inside the try block and we have a catch block that handles that exception, right, we can also throw in there just the base class exception if we have multiple that we're attempting to catch, and we can use polymorphism for that. But anyway, as long as we catch it, it will handle that. It'll execute that catch block's code, and then afterwards, if it was caught and handled, then it will attempt to just continue on and go to the lines after the try catch section, right? So it'll continue your program. So for example, right, we see in here we have this. We'll write this out. But essentially, we have this code that's attempting to call the length on a null string, right? So that will obviously cause a null pointer exception, which we then print out 2, and then at the end, because we handled the exception, we print out 3, right? If we did not handle this exception though, it would just fail, and we'd never see anything except for the initial line of 1, which would be no good. Now, the interesting thing here is we can also throw from a called method, right? So the try statement gets a chance to catch exceptions thrown while try part runs, right? So this includes exceptions thrown by methods called from within try. And so the interesting thing here is that, so if any of this basically what's happening here is if we make a method call, which, for example, parse int, right? If we gave it some just regular string, it would actually throw a number format exception, and that would not work out well. And we can actually see that happening here. So if we were to run the test and give it A and 7, it would throw a number format exception as expected because it doesn't know how to convert A into a number. So that's going to give us a problem. Well, the interesting thing about this is the try block will attempt to handle that, but as we can see, we don't have a catch for number format exception. We could instead just say exception here, and then we can, instead of saying print line, we can actually say print line, and then the message attached to it. So a dot get message, I believe will work. So then you say Java C test. And so in this case, we'll capture all the possible exceptions that can occur from our code. So if we run it just as this, we see we get 0 apparently. If we run test 6.0, we see a divide by 0. And then if we run AX, we'll say A7, it gives us 4 input string A. Essentially not very useful, but it gives us, what we want for now. Anyway, but we can see that we are capturing anything that's thrown here. On the other hand, if we defined just some regular method and it threw an exception that must be caught, then we would need to do some extra things, and we'll talk about that in a little bit here. So say, for example, we have some method called f, right? And we have this try, and then we're calling g. G throws an arithmetic exception that it doesn't actually handle itself. So then that will propagate up to the next place that from where g was called, which is in f. And so luckily we caught it here, right? So that's what we're seeing when we did the integer parse int, right? That throws the number format exception, and then we caught it here in main. So because it was not handled in the parse int itself. So in general, the throw and catch can be separated by any number of method invocations as long as you somewhere try to catch it. So we can think about like this if we go back to our concept of how activation records work, right? So if we have at the top of the stack Z, right? Z's activation record. If Z throws an exception and does not catch, then Z's activation halts. Then that exception is passed down to the next activation record Y. Y gets a chance to catch. If it doesn't, Y's activation stops and goes all the way down to the very bottom, which happens to be F in this case. And so if it's never caught, then it'll eventually get to the point where there's no more activation records, and then the program doesn't know what to do, and it just fails. So always wise to capture exceptions as you need to, or do a lot of really good testing for these types of things and input validation to validate that you don't need to necessarily capture things like arithmetic exceptions and number format exceptions. Anyhow, so handling exception handling like this basically is like a long distance throw, right? So and this is what we would consider to be an advantage of exception handling. Basically, the reason for this is that we have this capability to prevent the program from completely failing, where we just have some way to actually, not only to arrest the program's execution and keep it going in the case of bad things or user input causing problems occurs. We can now, interesting enough. So as we said, the try that we have here is the most basic form, right? Where we have a single catch, and in this case, we're catching all possible exceptions. Well, oftentimes when you have multiple potential exceptions that can occur, for example, here we have 3 different ones. We had the array index outbounds, number format, and then we also had the arithmetic exception that can occur, right? Straight up. The interesting thing about this is is that we can actually have a different catch for each one of those blocks. And so, for instance, we can say arithmetic, and then that will be the this will is it divide by 0? And then we can have the we can catch a number format. And say system.out to print line. So then that will tell us that we actually are, handling the number format exception. And finally, we were also looking at the array index out bounds. So in this case, we say all right. Now, interestingly enough, we could also put in to catch any other unknown exceptions that we don't care about. We can just say right. So now we have we're handling 4 different possibilities, right? And so when you do this, note that all the previous the first 3 exceptions here extend exception itself, right? They are subclasses of actually runtime exception, which is a subclass of exception. So that means that if we were to put the bottom catch above any of these, it would be the only one activated, right? Because it chooses the because any one of those will fill in for this exception because it is the superclass of all of them. So we have to be aware of that type of issue when this is occurring. Furthermore, you can also, and we'll talk about this, you can also throw an exception from within one of your catches that can be possibly caught by one of the ones further down. So that can also happen as well. So bear that in mind. Now, in the case that you're, maybe you have several exceptions, right, that you want to handle, that let's say you want to do multiple catches, but you have the same code needs to be executed in several of them, right? So for example, if we just I can't really think of an example but in case we want to deal with the arguments, right? So we have the array index out of bounds exception saying you did not provide enough arguments, and the number format really is talking about the arguments as well. And we could actually say you did not provide, and I need to learn to spell, you did not provide correct arguments, and we can actually use a enhanced form of the catch block, which uses a vertical bar separating the types. It's sort of like an OR, if you will, of the different exception types. And I need to learn to spell much better. Number format exception. We can get rid of this one. And so what will happen is this will capture, this catch block here will capture array index out of bounds exception or number format exception. This one will capture arithmetic, and the bottom one will capture anything we don't care about directly. And I think this should compile. And if we were to run this, so we'd have test and then A7, right? It did not provide correct arguments. And then same if we did just 7 or nothing. And then if we did 6, 0, we get the number, the arithmetic exception, right? And then if we provided, well, I don't know how to form any other ones right now, so let's not worry about that. But anyway, so that gives us the ability to use multiple catch parts, right? Which we just showed very similarly to that. And yeah, with the other one we could use, we use exception, but you could also use runtime exception. So any other runtime exception that occurs, we could just simply say some runtime exception occurred. Now, in the as it says here, if the exception from the try part matches more than one catch parts, only the first one will be executed, right? As I mentioned earlier. So if we had runtime above all these, or exception as it was before, above any of the other ones, that one will be captured regardless if it matches the ones below it. So, and furthermore, if we have these ones where we are using the multiple types in one catch block, any one of those will trigger that one. So bear that in mind. Oh yeah, and furthermore, you do have to note that if you were to put the runtime exception above, which we will try to do, right? Java does not really allow that. It will throw an exception during compiling. It'll throw a compile error. Right? So exception, so it says here, the exception, arithmetic exception has already been caught, which is this one, right? Because it's being caught by the runtime exception. And the same with the array index out of bounds and number format exception, because those are also runtime exceptions. So because we're already doing it up here, it's not going to work out very well for us. So what we need to do is we need to come up with something else that we can do. So we need to organize this correctly to prevent unreachable catch parts. So that gets us to the next section, which I'll put in part 2 of this.